Hi, I'm Matteo Stringher and I'm very happy to share with you what I've been doing the last 2 months at the HPC research group at the University of Luxembourg. During this summer I worked on the implementation of a plugin for Slurm to improve the energy reporting capabilities. Energy consumption is a real concern in the HPC world. The largest HPC center can request 5 to 10 megawatts, but even more in some cases. The Green 500 list shows and ranks all the best supercomputers in the world by gigaflops per watt, which is a common measure for the efficiency of such centers. More attention is paid on this topic, and thus it is clear that understanding in detail the consumption of each component is a key feature in such systems. There are many energy retrieval tools out there that can be used to collect information. They can be divided external sensors and internal monitoring. In our project, we have focused on this second methodology. So, pumping and liquid are general purpose tools that can be used to collect a lot of information at a low level. At the node level, we can use IPMI to collect information from the main board through the baseboard management controller. At a more fine-grained level, we can use RAPL distributed by Intel for their CPUs. On the other side, we can use NVML for NVIDIA GPUs. Slurm is the main job scheduler and research management system in the HPC world. It is adopted on 60% of the best supercomputers listed in the top 500. It supports natively IPMI and RAPL, but it does not provide any integration for the NVML library, so we have decided to focus on this one. Slurm through SPANK offers the possibility of developing complex plugins. So, when a job is requested and nodes are located, and as you can see from the right image, the node 0 manages and synchronizes the wall computation. Each node will run its own copy of the Slurm daemon that is used to do the computation. So, as you can see from the flowchart at the left, there are many function signatures in the SPANK library that can be used to implement your own code. For example, we have used the init function inside the Slurm step D to fork the retrieval process and then stop it at the exit. Our plugin can be invoked at launch time through the energy reporting flag. Along with it, we can set the sampling frequency. SPANK will load the energy plugin once the energy reporting flag is up. So the time series are recorded in the HDF5 format, which is very well known to the community, to the research community. The results are gathered and integrated over time at each step to compute the energy consumption in joules. So as conclusion, energy consumption data is stored for further analysis if needed. The user will be informed about the consumption of each step inside each job. The plugin can manage parallel jobs and all the contained steps. The plugin will seamlessly interact with Slurm, and the installation will be very easy for HPC administrators. In fact, the code must be compiled as a shared library and then distributed over the network on the nodes where the plugin will be used. We have decided to release the code as an open source contribution to the community. So, I would like to thank Praise for offering us the possibility of working abroad for 2 months, and a special thanks to the HPC research group at the University of Luxembourg for supporting us before and throughout the whole summer. Thank you very much.